Good afternoon, everyone. My name is Carol Werner. I'm the Executive Director of the Environmental and Energy Study Institute, and I am so pleased to see you here this afternoon with us as we take a look at the National Climate Assessment, which was just released 2 days ago. And of course, the whole purpose behind the National Climate Assessment was to really look at what is happening with regard to domestic climate impacts. We are so fortunate to have with us today two people who played incredibly important leadership roles with regard to the process and the organization and to the writing of this 800-plus page National Climate Assessment. Both of our speakers were involved in the Federal Advisory Committee and were part of the National Climate Assessment team, and as I said, played incredible leadership roles on this assessment, and they both have been involved with the prior assessments, as well as both having been part of the Intergovernmental Panel on Climate Change and being part of that team as lead authors for years. And in fact, both of them were part of the team that was recognized for their work with the IPCC in terms of receipt of the 2007 Nobel Prize. So we are very, very fortunate to have with us today Dr. Don Webbles and Dr. Gary Yeo. And a couple things why we are also very lucky to have them is because guess what? We are at the end of the academic year, and so they both are dealing with students in classes which finish up next week, and so we feel very privileged that they are taking this afternoon to spend this time with us, given that very hectic schedule as well. So both are very, very distinguished in terms of their professions. And of course, Dr. Yeo is a professor of economics and environmental studies at Wesleyan University, where he has been for more than 30 years. Dr. Don Webbles is professor of atmospheric science at the University of Illinois. And I think a couple other things that I just want to mention is that Dr. Webbles has done so much work and authored so many science articles, and of course his involvement with regard to the impact assessment has been really in terms of being the lead with regard to looking at the science. And on the other hand, we are very lucky to have today in terms of Dr. Gary Yeo, then the other piece in terms of really looking at what this means for adaptation, how to make our communities more resilient, what is really involved in terms of looking at these impacts. And he has spent many, many years really specializing and developing more and more information, doing so much thought leading with regard to adaptation. The final thing that I want to say before turning over the podium to them is that we all owe a little round of congratulations to Dr. Webbles because he just had a new grandson this week on top of the whole thing. So what better way to talk about something that is so critically important to our future? Dr. Webbles, Dr. Yeo.
Yeah, two things, I guess, before I start. Don's grandson was born on Tuesday, and when we were giving the stakeholder event in the White House, there were supposed to be slides behind us showing what was important about the 3 minutes that everybody was talking. And we thought maybe we could sneak a picture of the new grandchild in and say, this is what we're talking about, people. The other thing is, yes, I in fact missed the last day of class on Tuesday, but Linda and I, my wife, were walking down the 4th floor of Russell and walked past Senator Bennett's office. And Senator Bennett's father was president of the university. Senator Bennett and Senator Bennett's father and his grandfather all graduated from the university. I stopped in, and the senator gave me disposition for it and forgiveness for having missed class. My students didn't seem to be upset either, so I guess Okay, I'm going to talk for a couple of minutes on the National Climate Assessment, the process, where it came from, get to highlighting the high-level results that were emphasized in the release, and then turn it over to Don to talk about the science. And then I'll come back for a couple of minutes to give you a flavor of the regional diversity of the results across the country. So if I can do this without messing this up, yay. The National Climate Assessment is a product of something called the Global Change Research Act, which created the United States Global Change Research Program. The act was crafted in 1990, but I found out this week that it was actually passed in 1995. And for those of you who are thinking about the political feeling in this town in this year, it's astonishing to report that that act was passed in the Senate 100-0, and it was passed in the House by voice vote. Its purpose was to provide the Development Comprehensive Integrated United States Research Program and so on and so forth. Section 106 says that not less frequently than every 4 years, the Council shall prepare an assessment, a national climate assessment, that integrates and evaluates, analyzes current trends and effects, and helps to mobilize reaction. The first National Climate Assessment was released in the year 2000. The second missed the 4-year deadline by a bit. It was published in 2009. There's the covers of them. I have to remember to move the slides that you're seeing, not the ones that I'm seeing. And the real question that a lot of people have been asking is, so what's new? Some of it was, so what's new since the review draft last year, but what's new since 2009? And as the economists in the room, the first thing I want to suggest is what's new is the risk-based framing that allowed us to organize our thoughts chapter by chapter, region by region, according to at least a qualitative definition of risk, that it is likelihood times consequence. And that allowed a fairly deliberate evaluation of what it was that we wanted to talk about and how it is in traceable accounts we wanted to record how we came up with our conclusions. An example of what it allows you to do is that it allows you to recognize that climate is simply another source of stress and another source of possible change in particular sectors. So here's just an example. Climate is only one of many factors affecting water supply availability. So these are maps of water supply availability in 2050 along a particular scenario. I think it must be the high scenario. Over to the left is without climate change. There is change in water availability, percentage change going down by a little bit or a lot. But with climate change, you get a lot more colors scattered around the country. Climate change is what the security and defense community calls a risk enhancer. It isn't necessarily the absolute cause of one thing or another, but it amplifies the manifestations of other sources of stress. So what is fundamentally new about the assessment? There are many new topics that had never been covered before in a National Climate Assessment. The first two, oceans, a special chapter on coasts, a special chapter on urban, rural communities, land use, indigenous peoples. There is a cross-sectoral chapter that links energy, water, and land. And all of these were very exciting, and the committee that helped organize things got a lot of encouragement from a lot of people to try to do these sorts of things. There is a brand new format for the release of the document. One of the talk show hosts on Tuesday night said, "I can tell you what's causing climate change. It's another 842-page assessment, and it's just killing the trees and the forests." Wrong. That 842-page full assessment report is published entirely electronically. You will not find an 842-page brick holding up anybody's door. It is completely interactive. You can go on there, and I'll give you the website at the end. You can go on there, go to a chapter, go to a map, click on the map, get the underlying data, click on a reference, get the underlying reference, click on a reference as well, and get an evaluation of its credibility through the review process and a variety of things like that. It's fun. I encourage you to do it. I think it's NCA 14, or I'll look it up. We also have published highlights, about an 85-page summary document and a 20-page overview that you had an opportunity to pick up. It will be linked to GCIS, a Global Change Information System, and it will include, the big report includes these things called traceable accounts, which not only indicates the references that were used to support the particular conclusions in the document, but also the means by which the authors came to their confidence conclusions. Do I have medium confidence in this or high confidence in this? It's a risk-based approach, so we were not held to the necessity of reporting only very high confidence conclusions. If there were high consequences associated with a medium confidence conclusion, it was perfectly appropriate to put it in the report. There was an extensive review that evaluated how we did with that. The National Academies of Science conducted 2 reviews, one of the first draft, which also went through public review for 3 months, a year and a half ago. The federal agencies made a couple of review passes. The National Academy of Sciences reviewed how we responded to all of the comments. All of the comments are available publicly, and all of the responses are available publicly. The Academy passed it on. There was a final, very thorough government review before the administration finally put it forward last Tuesday. And the links to the underlying data, the references, and the traceable accounts are all available electronically, and are all subject to Information Quality Act review under NOAA. So the sectors that are covered: water, energy, you can read them. They are the usual sectors that you would think about. Agriculture and human health receive particular attention. There are 8 regions. From the Northeast, Alaska is big enough to be its own region, the Southwest, and so on and so forth. One of the fundamental differences between the IPCC and the National Climate Assessment is that the IPCC has continents, and the United States is just one part of North America. We have one country, and we have 8 regions here. And the focus of the organization of the report was to look at the diversity of the implications of climate change across those regions, so that you can understand the sources of risk and the differences across the regions, and build from the bottom up a picture of what was going on. Then there are a couple of new chapters on responses, one on information for decision support, because from the very first day, the point of creating this document was to help inform decision makers at all levels, from individuals up to the federal government. There's a chapter on mitigation that talks a bit about how you structure mitigation and what's going on. a chapter on adaptation, a chapter on research needs, and what we call a sustainable assessment product, or the actual first product of the National Committee, Advisory Committee that produced this National Climate Assessment, was a recommendation to the U.S. government to promote and fund a sustainable assessment process so that over the next 4 years, because by the way, there's another one due in 2018, there will be a process of research and investigation that will be focused on what we couldn't do as well as we wanted to so that we get around to doing it the next time. Somebody else, not me, will have more information to fill in the gaps and make some progress forward. The 4 major results in shorthand. Human-induced climate change has moved firmly into the present. This is no longer something that's going to be happening in the future. It's no longer something that only happens overseas to people that we don't know. It's happening now across the United States. Impacts are apparent in every region in important sectors including health, water, agriculture, energy, and more. So one of the things that we could do better than the 2009 report is we had a lot more observations of what is actually going on, and we could calibrate that to particular regions, and so that we can say that every region, nearly every person in the country has seen some implication of climate change. For some, it's the birds that show up a week earlier or the flowers all bloom at the same time. But for others, it's very heavy downpours that cause their cellars to flood. For others, it's very, very heavy downpours in intensity and frequency of extreme weather events that makes the streams and rivers flood, or droughts, or wildfires that are associated with heat waves and droughts. People are seeing that not just on the news, but when they look out the window. Americans are already feeling the effects. They're particularly feeling the effects through changes in extreme weather events, like the events I just talked about, but also with respect to sea level rise. And the manifestation of sea level rise increasing the intensity of the face of the storms when they make landfall. It's not just hurricanes, just a regular nor'easter in the northeast is now creating much more damage than it used to because the seas are a little bit higher and the storm surges are a lot higher. And we heard a day ago that this report is deep green. When I heard that, I thought that was a compliment, but what it means is that it's very pessimistic and very dark. None of you are smiling very much at the moment for all of this bad news, but a good deal of what's in the report is actually coverage of opportunities for people to be able to respond to the risks of climate change, either by undertaking actions that reduce their contributions to global emissions that are driving climate change, or through their actions and investments in adapting to the climate change that's already happening, that they are seeing, and increasing their preparedness and resilience in anticipation of the climate change that would be coming forward. Okay, with that, I think we'll turn it over to Don.
Thank you, Gary. Thank you all for being here, by the way. Really appreciate it. You know, it's not often I get to give a presentation where I'm actually first in the alphabet. Just never happens. So I feel very, very happy with that today. Gary mentioned what's new. And if we look at the science of climate change, we have a great deal that's new. We have 5 more years of additional data, many more analyses of the climate system, both of the past climate system, going back thousands and millions of years, but also better analyses towards looking at the future as well, beyond any other assessment. And as Gary mentioned, our focus here is on the United States, which is very different than the IPCC assessments that also likewise bring together a large group of scientists and experts. So what I'm going to do today is just give you a quick go through some of the science. Everybody always hearing about global warming, and it's something the media created years ago. It's not the scientific term. We've always said climate change because this is so much more complex than just looking at temperature. And it's not just the simple change in temperature, it's the changes in severe weather events that particularly concerns us these days because of the potential impacts on humanity and ecosystems. This graph just shows you 10 different indicators of the fact that our climate is changing, that it in fact is warming. And so one of those is surface air temperature, but the oceans are increasing in temperature, the upper atmosphere is increasing in temperature, the glaciers are melting, sea ice is melting, snow cover is decreasing, in particular parts of the world. Amount of humidity in the atmosphere is increasing. As the atmosphere is warming, basic physics tells us that it should hold more water vapor. And the observations indicate, yes, it is doing that. And that's part of the reason when we start talking about extreme precipitation, why that occurs. So we have physical information to back up what's being observed. Let's just go look at the temperature record. And this is kind of a simple way of looking at it, just looking at decadal. We've seen about a 1.5 degree increase in temperatures globally over the last century and a half, century plus. And if we look at the last decade, this was the warmest decade on record over that time period. The last 3 decades, and you can see for the last 4 decades now, it's been progressively warmer. And on top of that, those last 3 decades appear to be, based on analysis of paleoclimate, past climates, the warmest in at least the last 1,300 years, and probably much longer than that, maybe out to 2000 and beyond. We have some data out to about 2000. We have data going way back much further than that, but you don't get the decadal data going beyond that. It tends to be in longer periods of time going beyond that. And so we feel very confident that this is a really unusual warm period in the Earth's history. And so it's not surprising that we're seeing those many indicators of change. This shows you the changes from about 1900 to now in the U.S. In the lower left, you can see the trend of temperatures in the U.S. We've also seen about a 1.5 degree Fahrenheit temperature increase in the U.S. And like the global data, progressively warmer the last 4 decades. And now if we look over this time period, not every place is warmed, nor do we really expect it to for various reasons, but most of the U.S. has warmed and has warmed extensively. The one exception is primarily the southeast. In addition, we've seen an increase in frost-free season, which means a longer growing season for plants, and that's a good thing for farmers. I'm a son of a farmer, so I'm always interested in things that affect agriculture. But throughout the country, we've seen an increase in the growing season, over 2 weeks in the West, and about a week and a half in the Midwest, where I live, and similarly for the Northeast. We look at precipitation. Precipitation has also increased across the U.S. Not too surprising, given the increased amount of water vapor I mentioned before, but some places have decreased. And that's also not surprising. If I'm going to use a little sciencey jargon here, that we expect that there should be a movement of the tropical dry zones northward, which would tend to make the southeast and southwest drier, and that's what's been happening. And this didn't come out the way I expected. It should have been larger lettering, but I mentioned before, we're seeing certain types of extreme events, trends in certain types of extreme events are changing. Some cases increasing, some cases decreasing. Heat waves are generally increasing across the United States. We're getting many more hot days than we used to. It's another way of putting that, but heat waves are like 3 to 7 day or longer events. We're also seeing a decrease in cold waves. Now, this year on the East Coast, or the eastern half of the United States, that was kind of an exception to what has been the general rule. I could talk all day about that, of those events, but that's the exception of what we've seen over the last 3 to 5 decades. I mentioned already that more precipitation is coming as larger events. I'll show you that in a minute. And all this is based on observations, purely observational based. Increasing risk of floods in some regions, and I'll show you that. I think I have a slide in that, I'll see. But we're seeing an increase in floods in the Northeast and the Midwest. And meanwhile, we're also seeing an increase in droughts in some regions, particularly the Southeast and the Southwest. And we're also seeing an increasing intensity of Atlantic hurricanes. Now, some of these I'm going to talk a little bit about. This is the observed trends in heavy precipitation. The graph on the left looks at the last 50 years, 1958 to 2010, a little over 50 years. And it's relative to the top 1% of the local precipitation events in each of those areas. So it's rainfall and snowfall combined. And what kind of change has there been in the likelihood for such an event? And we've seen, for example, in the Midwest, a 37% increase, a 71% increase in the Northeast, and most of the nation, with the exception of Hawaii. Actually, this went through 2012. We updated this graph, which is why Hawaii suddenly went negative. It used to be positive. Those extra 2 years was very dry in Hawaii and caused it to go negative and didn't have large precipitation events. But generally, we're seeing this an increase in precipitation when it comes, even in the Southwest, where you're not getting as much precipitation as you had before. When it does rain, it's likely to rain as a larger event. Analysis also show that generally we expect to see an increase in the number of dry days in between rainfall events for much of the nation, which is kind of surprising. It was surprising to me, actually. So this is the floods. This is based off of analysis by USGS, looking at riverine floods around the country. Many rivers are affected by dams and so forth, and that affects the analysis. And so they tried to separate that out. But generally, nonetheless, you see an increase in the amount of floods in the Midwest and the Northeast, and generally less floods, reduction in floods in the Southwest. Now, a lot of analyses in recent years have been going into attribution of climate change. Why is it we will say that the reason the climate is changing is due to human activities is based on many different pieces of evidence. But in addition, we used to say, and we could talk about all of that if you want, but in addition, we used to say we can't say anything about a particular event. We get a heat wave, and we'll say, well, we can't really tell because it could have happened naturally. Well, now scientists are going back and looking at past events. It's a very complex analysis to do this, and saying, well, would this event been as likely to have happened if it hadn't been for the fact the background climate has changed? And we're finding it for many events that, in fact, they would have been much less likely to happen. So one example is the 2011 heat wave and drought that greatly affected Texas and Oklahoma. And I think we're still feeling the extent of that in beef prices. I think that's probably one of the contributors, at least, to why we're seeing such high beef prices right now. And the top right graph shows the number of 100-degree days in 2011, and you can see it's really dominated by that region. We usually expect some in Southern California and Arizona, but not like this in Texas and Oklahoma. And if you look at the lower left, it shows you this kind of big, it goes year by year and looks at the amount of rainfall versus temperature in that Texas region. And what it shows is 2011 is that red dot way at the top there, where you had extremely high temperatures, extremely dry conditions, way outside the norm of previous years. So this was a very unusual event, and yet the science analysis tell us that this event was twice as likely to have happened because the background climate has changed. And we can say that about some other events too, which I won't go into here today. Well, if we look at the attribution to why we say it's related to human activities, I'm not going to spend a lot of time in that, but we know it's not the sun. The top part is just the temperature change over time, the blue. The red shows you the changes in solar output that we measure at the top of the atmosphere from satellites. And you see the 11-year sunspot cycle in that. The variation in the sun is very small. So that sunspot cycle is not having a huge impact on our temperature. It has a very small impact. But if you were to analyze that carefully, you would actually find that the solar output is actually decreased very slightly over that time period, very, very slightly. It cannot explain why we've seen this very significant increase. Likewise, natural cycles cannot explain what we have seen. We do have paleoanalysis going back to the end of the last ice age, 20,000 years ago. We have analysis going back much further than that. But there's no indication that this should be related to a natural cycle. There's no data that would tell you that it was related to a natural cycle. Whereas analyses we do that include the effects of human activities match up very well with the observed temperature record. So that tells you that the primary cause, and you can see a lot more detail about this in the assessment, is human activities, and particularly the burning of fossil fuels in from power plants and vehicles and so forth. Land use change is also important, deforestation, particularly in the tropics, and it accounts for the order of 15% or so of the change. Corresponding to that, by the way, is an increase in carbon dioxide to almost 400 parts per million in the atmosphere. Even as a scientist, I find it amazing. 400 parts per million means 400 molecules per million molecules of air. It's a tiny amount in the atmosphere. Yet these molecules are extremely important because they absorb infrared radiation that's emitted to the Earth. So the sun sends energy down in the ultraviolet and solar wavelengths, primarily. That's absorbed by the Earth. The Earth reemits, largely because of the temperature of the Earth, in the infrared. It's kind of basic physics. And the infrared energy would just go to space if it wasn't for these gases called greenhouse gases in the atmosphere. And this planet would be extremely cold. We would not have life here as we know it without these greenhouse gases. But what we've done now is we've increased one of those greenhouse gases. We actually increased several of them, but one of the most important ones is CO2, carbon dioxide, to 400 parts per million. Its natural levels are more like 200 to 280 parts per million. And we have not seen 400 parts per million on Earth for the last 1.5 million years, roughly. And if we can go back and we can explain why, why was it that high way back then when there were no humans, but there was good natural causes for that. But we just have not seen anything like this. So we're seeing something very unusual that's leading to the temperature changes we're observing, but it's also leading, as we continue to burn fossil fuels, to more and more increase over this century as we go through it. So this shows you projections of temperature change through the century. It shows you two scenarios, a low case and a high case. Now, this isn't as low as you can go. We can choose to reduce our emissions greatly and be lower than this. Some of the new scenarios actually go through that kind of analysis. Or it could be higher. The high scenario here does not assume we burn all the fossil fuels by any means. And so you can still go higher in this. Unfortunately, the rate we're going right now, we're following the high case at best, and maybe even worse than that. Well, we're talking about a change in temperature, notice the range, by the way, for each of those colors. That denotes our uncertainty in the climate system. Primarily, so we have uncertainty in the scenarios themselves, because how much choice are we going to make about continued burning of fossil fuels and put more CO2 in the atmosphere, but we also have uncertainty in the models we use to analyze and particularly in what's called climate sensitivity, which I won't go into here, in terms of just how sensitive are all the feedbacks in the Earth system to responding to this initial forcing on the climate. Well, the upper level of change is up to 8 to 9 degrees Fahrenheit temperature increase. Put that in perspective, the last ice age was about 15 to 20 degrees colder than now. So we're talking about an appreciable increase in temperature relative to an ice age. We know how, an ice age, I don't know about here, I know in Illinois, the ice was all the way down to where I live. So I can't speak to what it is in Washington, D.C., but it's probably pretty similar. So a great deal of ice was here, and it means for much colder temperatures. But we're talking about an appreciable warming, very different than what the Earth is used to, or particularly people on Earth and the other life that live here. To give you an idea of what this means across the nation, these are the projections by the end of the century, the last 20, 30 years of the century, relative to now, the 1970 to 2000 time period, and various parts of the country are as much as 9, 10 degrees warmer. Expect to see more changes in summer than in winter, but both are quite large. If we follow the low emissions case, we get quite a bit smaller. It's 4 or 5 degrees. That's part of our choice. Looking at precipitation, this is a high precipitation case. Low precipitation cases tend to be, low emission scenarios tend to be similar looking, but less in magnitude. We see a significant increase in northern latitudes in precipitation. The hatched lines mean we have high confidence in those analyses. Where there's white indicates that we don't have data that we feel confident in that is much different from the way it is now. And where it's brown, we have pretty high confidence that it's going to be drier. So if you look at the Northeast and the Midwest, we expect an increase in precipitation in the winter and spring, more of that precipitation coming generally as rainfall compared to the past, although we're still going to get quite a bit of snow in where I live. In the summer, generally a drying throughout the country. And in the falls, maybe not too dissimilar from what we have now. Now I'm going to change real quickly. In the Midwest, I don't worry too much about sea level rise, but certainly the East Coast and most of the other coastal areas of the country, we need to be doing that. And we did a fresh analysis of how sea level rise could change over this century. We've seen about an 8-inch increase in sea levels over the last century worldwide. And over this century, we expect to be something like 1 to 4 feet. Now, it could be outside that range, which is why we show, even other bars that go a little higher, somewhat higher and a little lower. But the most likely case is 1 to 4 feet. Well, that's enough to be quite disruptive to many locations. A 1 meter change or 3 foot change would put a lot of Miami in great jeopardy, for example. And that doesn't account for storm surge, the effects of hurricanes, and so forth. We already see in some places like Miami, Santa Cruz, California, Norfolk, Virginia, some others, when they get a really high tide, we're already flooding the streets. So as sea levels get higher, you're going to have more and more of those kind of issues. Along with the change in sea level is also because of the increase in carbon dioxide and the fact that the majority of the carbon dioxide we put in the atmosphere actually ends up in the oceans, that we're also increasing the acidity of the oceans, making them less basic than they are now. And in some locations, such as the Northwest, we're already seeing effects from that. For example, a reduction in clam size as a result of the increased acidification. And I'll leave it at that. This was just an extra graph. So.
Okay, two more slides that are hard to read, but if you have picked up the climate trends and regional impacts for Pager, these two slides are on the back. And I include them essentially to give you an idea of the diversity in the impacts across the regions that we have either observed or projected. Notice carefully that the title is Selected, Observed, and Projected Climate Change Impacts. So for the Northeast, communities are affected by heat waves, more extreme precipitation events. You saw the map that showed the observed increase in extreme precipitation events, and coastal flooding due to sea level rise and storm surge. Isn't necessarily Hurricane Sandy and Irene. It is a big nor'easter or an ordinary nor'easter that's doing that sort of thing. The Midwest doesn't have much in the way of sea level rise concerns, although they do have some big lakes to their north, but they have longer growing seasons, rising carbon dioxide trends, a variety of things like that. So the point here is the diversity that is picked up by the regional focus of the National Climate Assessment in building up from communities to states to the entire region. So that's one set. Here's another set. Those are the beginnings of the answers of so what. So what number 2 is the following. In all of the stories, in all of the analyses of the local impacts and the risks associated with what we've observed so far in particular, but what is projected, there are opportunities for response that reduce the likelihood of bad events happening or reduce the magnitude of the consequences of an extreme event. Those are the adaptation illustrations of choices that are available to people to make, and their futures will depend on the choices that they make today. The point of the two emission scenarios was to make that point with respect to emissions. The choices that we make over the near term and the slightly longer term about the pace of emissions will have a large effect on which of those futures we get, which of those temperature increases we get, which of those associated changes in the other manifestations of climate change to which we will have to continue to try to respond. So that the fundamental take-home message that takes us from dark green to something that gives you an understanding that it's up to you at the federal government, at the state government, at the local government to communicate these risks, get people and businesses to understand that climate is another source of risk that they need to take into account as they make their decisions in the short run and the long run. The very long run decisions about infrastructure is why that 6-foot sea level rise scenario is there. If you're building a building near the shoreline, you better take that one into account just to be safe. It makes economic sense to do that. So hopefully the communication value of the Third National Climate Assessment will help engage in communication at all levels of decisions so that a recognition that the old climate normal is broken and we don't know what the new climate normal is going to be, we're on our way to that, heaven only knows what it's going to turn out looking like, is something that people can take into account. So we thank you for your attention. Now the rest of the time is on you, and will you moderate? Thank you.
Thank you very, very much. Great. So now we have about half an hour for Q&A. So if you've got questions or comments that you would like to make, please identify yourself, and the floor is yours. Any questions or comments? We've got two great people here who have spent a lot of time on research on this.
Yes, Phil Emmy from the Friends Committee on National Legislation. I was hoping you might address the irony that arises out of this past winter's experience when we have had such a difficult time with a very cold winter, associated, I understand, with a weakening of the jet stream because of the diminished temperature gradient between the Arctic and the tropical zones. In a year when, if I'm correct, that we have had the warmest mean global temperature around the world, leaving the most powerful the people of the most powerful nation in the country under the impression that global warming is diminished.
Okay, thank you. So often when I start public talks these days, I'll show a graph that is from NOAA, from one of the satellites, showing the temperature in January over the world. And red colors in that graph are way beyond normal, yellow's beyond normal, blue, light blue is below normal, and then dark blue is way below normal. And of course, the whole half of the U.S., the eastern half of the U.S., was covered in dark blue back in January. And yet, we're still trying to understand exactly why the polar vortex broke up the way it did and why this was such a strange year. But we are generally seeing larger transitions in latitude between in the jet stream, so that you're seeing bigger waves in the jet stream than we used to see. And we're still trying to understand exactly why that's occurring. There's a hypothesis in the journals, published papers, that suggest it could be related to the decrease in sea ice in the Arctic, and that's driving some interesting dynamical relationships. We don't, the community hasn't fully accepted that, nor have I, as the basis. There's a lot more information we need. However, if you go back to that map, what it showed was the vast part of the world was in red. Australia was breaking record temperatures. Europe was seeing record temperatures in winter. China was generally warmer than normal. And here we sit in the eastern half of the U.S., and we were way below normal because of all this Arctic air coming down our way. So it ended up that January was the fourth warmest January on record, despite what we were seeing, and all the people, many people in our region saying, well, obviously there's no global warming because look how cold it is today. We actually heard that earlier in the week. I got a text from somebody that said, well, it was 30 degrees in northern Illinois this morning. How can you be talking about global warming? Well, you have to understand the difference between weather and climate. Climate, we're talking about the long-term changes in weather, 20, 30-year statistics. Not what happens today. So Mark Twain put it, climate is what you expect, weather's what you get. And so we're looking at these long-term changes, not just what's happening in a given time period. And for some reason, people don't seem to grasp that. And they also don't look outside their window and say, oh, wait a minute, the rest of the world is really warm. It's not just us and where I live. So, which is interesting.
Adam Sundberg with the U.S. Climate Action Network. I have a question about the review process. I know, Dr. Yeo, you touched on it a bit, and I'm curious how this process worked. How were the reviews solicited? How were they integrated, or weren't they integrated into the final assessment?
Thank you. The review process was long and extensive, which makes us think that this assessment was perhaps the best reviewed assessment of any type that's ever been put out there. It's certainly far and above in its rigor what you typically get for a scientific article that you submit to a journal, where a couple of people read it, and if they don't like it, that's tough. If they do like it, they put it in the newspaper or they put it in the magazine. It started with an initial draft from a collection of 300 authors that were selected by something called the National Climate Assessment Development and Advisory Committee. They were organized across 30 chapters. The IPCC-like structure, 2 CLAs, and then some lead authors, and then some contributing authors. They prepared a first draft that in January of 2013 was put up on a website and made open for public comment for 3 months. So on April 14th, that 3-month period closed, and we got about 4,000 comments. At the same time, it was submitted to a committee of the National Academy of Sciences, which reviewed it as well. And by April 14th, they prepared their report of several 30 or 40 pages on each chapter from experts, from the committee as well as outside experts that they solicited. All of those comments went back to the author teams. They were instructed to respond to each comment and make changes as they saw appropriate, or explain why they weren't making those changes if they didn't think they were appropriate. If a review comment suggested a new piece of literature or a new collection of literature that had been omitted or just recently published, the authors were instructed to take that literature on board if they felt so obliged. All of those comments and the responses to all of those comments are in the public record, and people can go and look at that. That second revision went out for agency review, went back for the National Academy of Sciences for them to assess their degree of pleasure with the reactions to the comments that they submitted and whatever they had heard about the public comments. In the meantime, a collection of review editors went over the comments and the changes to make sure that, in their expert opinion, the responses were appropriate, and they all had to sign off on what became the second draft. That we then began to really ramp up the revision to make it something that people could actually read, rather than something that would just be for the scientific community. So we had an outstanding science writer named Susan Hassel, who worked with all of the author teams to go over their text and go over the summary of their texts so that it was readable. And if you look at scientificamerican.com, she gets a shout out for the success and the effort that she made for doing that. It then went in for very extensive government review and a short turnaround response for that while we were writing the highlights, which also went in for an extensive government review. In December, just before Christmas, so the National Climate Assessment Development and Advisory Committee did in fact meet its statutory requirement of having a 2013 date on what we submitted, went into the administration, and there it went through another thorough investigation and review in conversations with experts that the administration picked. And the highlights document had exactly the same thing. So finally, it came around to an agreement by the administration that they were pleased with it. We went back to the National Climate Assessment Development Advisory Committee and asked for their approval of the final draft of the document. It should be noted, and this is actually important, I'm going to raise my voice in a second, but all of the decisions by the advisory committee were made on the basis of consensus. We had 44 voting members of the advisory committee, and every single one of them had to agree to any proposal that was on the table. So the proposal was on the table on Tuesday morning at 8 o'clock. Is there anybody on the committee who has an objection to the final version of the draft, of the report? And nobody spoke, and so we had a consensus agreement to put this forward. Now I'm raising my voice. That does not mean that everybody had 100% confidence that every conclusion in the report was right. It was that they agreed with the assessment of the authors about their confidence in the degree to which we could advance that as a conclusion that people should take into account in their risk-based management decisions. So if there was a medium confidence conclusion about some particular high consequence event, the consensus meant that the 44 people on our committee agreed with that assessment of confidence and consequence. It didn't mean that all 44 thought that event was going to happen next week. Then at, I guess, 9 o'clock that morning, there was a press conference, and it was out. It was on the web at 8:45, and you could get it.
Just one real quick thing. I've been asked a lot this week, what happened between that January 2013 document and what came out. In almost all cases, it was better clarity, making the message clear. I know in my chapter, we wrote the first, we wrote the chapter, and we're scientists. We're not used to writing for the public. So a lot of clarity came out of those reviews, and then Susan and her team went to work and also helped us further clarify the message. So, but it's the message we had in the first place. It's just, it just speaks a lot better to the American public.
All of those revisions were approved by all of the authors. They signed off on all of them, but from day one, the purpose of creating this assessment was to communicate to the American people, all of them. And so as the Scientific American article suggested that we did a good job without dumbing it down. And so we're very proud of that.
Which is such a major accomplishment. And in terms of when you think about the whole process and how in-depth it has been and how many people have been involved in terms of the leadership of Professor Wibbles and Professor Yo, and the fact that all of these folks were donating their time, which is incredible to think about in addition to go through this whole process. Question back in the back. Mm-hmm.
Oh, I'm sorry. Hi, I'm Agatha Wine. I'm with the U.S. Department of Energy, Office of Energy Efficiency and Renewable Energy. I'm wondering if you could just comment briefly on the extent to which you did or did not discuss the causes of climate change in the report, rather, or were you just focused on the effects of climate change? And if so, can you just talk a little bit about why that might be?
You wanted to know about the causes of climate change? Did I capture that right? Yeah.
I'm wondering the extent to which the report discusses the causes of climate change, or does not.
Yeah, so I did mention this earlier. I actually led 3 chapters, 2 of which ended up being appendices. The first one is our changing climate, which is chapter 2, which is the science of climate change. Then there's an appendix that goes into a lot more detail on that science for those that want that. In fact, it was funny because some of the science agencies looked at the appendix and they said, well, why isn't that the chapter? That's what we want to see. We want to see that, not that other stuff that's written for the public. And then the third one was frequently asked questions about climate change. And you can get all that stuff off the website. So in the main chapter, we do discuss why we attribute the changes in climate to human activities primarily over this last 50 years. I referred a little bit to some of that information in my presentation, but just a little bit. There's like 4 major types of pieces of evidence that are mentioned there. Then we go into even more detail about that in the science appendix, so you can see all of that there. And because we were trying to limit the things, we also refer to a lot of journal articles, and so you can go see all the journal articles. Every statement is backed by papers that have been published in peer-reviewed journals. So, in reports put out by government agencies or other reports that have gone through a quality assurance analysis, and that's all described in the report. So every statement we make is really backed by that. But you can see that discussion. You know, the one graph at the end of my talk that I ended up putting up accidentally was the increase. Why is CO2 increasing? What we're seeing due to the burning of fossil fuels and so forth, and the data we have in that from what is it, EIA, Energy
Information in the Ministry.
Yeah, I'm terrible at this. That was from there, and that's a graph that actually appears in the appendix. I think is where it appears.
I'm not sure if you were also asking about sources by country, by energy source, by whatever. The mitigation chapter spends a good deal of its space talking about where emissions are coming from, what types of fuels they're coming from, where they're coming from. Focuses in on the U.S. contribution to global emissions, which is about 16%. Focuses in a little bit on what has happened over the last 6 years, an interesting selection of number of years, so that it puts that in perspective. It also speaks to the range of options that are available at all levels, federal levels, and from legislative action that may or may not be forthcoming, regulatory action, state action, individual action, community action, university president action, corporate action. You should know that ConocoPhillips and Chevron both had representatives on the National Climate Assessment Development and Advisory Committee, and they also were part of the people that agreed unanimously that they should put this result forward. There you are. You're still standing up.
Okay, great, thanks. I wanted to ask if you could talk a little bit more about some of the economic impacts in terms of what was concluded through the assessment in terms of thinking about risk management, what this means for everything from sort of emergency responders in terms of dealing with the extreme events, and what does this mean for insurance agencies in terms of thinking about insured, uninsured consequences?
How much time do I have for that one?
I know, I could give you the rest of the day and then some, right?
Well, start out with the perspective of and the way the assessment was organized. It was regionally organized, and it was focused on topics that were important within those particular regions by experts who lived there. And so there was no attempt and no expectation from the very beginning that we would sit down at the very end of this process and add up all of the numbers and get a national estimate. Nor was there a presumption that all of the damages would be calibrated in currency. If it's human lives you're talking about, write it down in human lives. If it's ecosystem services, write it down like that. Calibrate it as best you can. If it's health effects or human welfare effects, calibrate it the best you can. And report ranges or report your methods so that it highlights the source of the uncertainty, the likelihood part of risk, and your evaluation of the consequences and whatever is the most appropriate metric. So for example, New York City spent an enormous amount of effort a number of years ago to collect and produce information about observations of their climate and projections of what their future climate would look like in the short term, in the medium term, and even into the longer term. And that was done to inform an adaptation task force that was comprised by 25 or 30 people, half of whom came from city agencies and half of whom came from the corporate sector. to look at their infrastructure and try to think and the people that worked for them, and try to think about where their sources of risk were from climate and what they could do to try to reduce those risks, either by reducing likelihood or reducing consequence. The city as a whole did that as well. The Adaptation Task Force came up with a list of 40 or so adaptations that were deemed to be relatively urgent, and they undertook some of those. But the city itself looked at their emergency management responses in anticipation of major sources of risk, as well as after the fact. One of the things they realized was their evacuation plans in the case of a large coastal storm hitting New York were completely inadequate for what had happened because of sea level rise and climate change to the manifestation of such a storm when it came on shore. And so by the time Sandy arrived, they had changed their emergency evacuation plans so that 8 hours before landfall, the subways were shut down because they knew the subways would flood. And that probably saved thousands of lives. That is a metric of benefits of a response that you don't have to put in dollars and cents.
Right.
Some of the other ones in New York, you have to put in dollars and cents. But Boston is doing the same sort of thing. Chicago has been active. Seattle has been active. Donna's going to comment on Chicago.
Okay. So in 2008, I got asked by Mayor Daley to lead an assessment of how climate could impact the city of Chicago, and resulted in what's called the Chicago Climate Action Plan. And one of their big concerns was the large heat wave in the mid-1990s that resulted in a week-long event, 100-degree days, many of the nights above 90 degrees, well in the 80s and above, that resulted in 850 or so deaths in that region. Largest event they've ever seen. And he asked, well, what's the likelihood of such an event in the future? And so we looked at that in our analyses and came to the conclusion that by the end of the century, if we follow that high emissions pathway, that you could see 3 such events every year. So what was very uncommon becomes common. As a result, the city put in adaptation measures for dealing with heat waves, which it didn't really have before. And in 2012, when we had extreme heat in the Midwest, large drought, for those who remember, the city had a similar sized heat wave. I don't know if it was quite as bad or not, but instead of 800 and some deaths, they ended up with about 20 deaths. And a lot of that is because of the measures they had been put in place for dealing with particularly the poor and the elderly in terms of making sure that they were safe and were in the right places during that week so that they could get through that event.
Okay, you also asked about insurance, and this isn't in the report, but Rosina Birnbaum told me that the President's Council of Advisors in Science and Technology had a report from an expert from an insurance company that said that 2011 set the record for insurable losses around the world. In 2012, didn't set the record for insurable losses around the world, but the top 5 insurable losses, catastrophic events, all happened in the United States. Now, insurance has responded to that by pushing for changes in flood maps on the coasts and along rivers. And that is finally starting to come to pass, notwithstanding the fact that every time they had done that up until last year, people who work on buildings like this would write letters to NOAA and FEMA and say, you can't do that. We protest because insurance rates are going to go up. Well, insurance rates were underpriced and the risk was going up. Insurance companies understood that, and they were deciding that if we can't raise our rates, we're just not going to sell insurance in this place. So all of a sudden, these people didn't have any insurance. For a mile north of the south shore of Long Island, you couldn't buy home property insurance. And if you had a mortgage and couldn't buy property insurance, you were in trouble because the bank was going to insist on it. So what has happened? Well, what has happened is the FEMA mats have changed in many, many places in the response to Governor Christie and Mayor Bloomberg sort of shoving their weight around. It happened in about 3 weeks. Insurance rates have gone up spectacularly along the coastline in the Northeast. But insurance companies have also recognized one of the opportunities that I was trying to put forward in the risk-based framing, that if they could tie the increased premiums into a contract with the homeowner to undertake certain adaptations to lower the consequences of a high flooding event, then they would be willing to dramatically reduce those those insurance premium increases. For communities like Greenwich, Connecticut, $1.5 million house on the coastline saw their property insurance go up by $25,000. But if they raised their house, raised their $1.5 million mansion, those insurance premiums would only go up by $4,000. That was a $21,000 a year reduction in insurance premiums. If you do the internal rate of return calculation, that was a 14% rate of return on the investment of $120,000 to raise the house. They couldn't find that return anywhere else, so they took it. And so that's a lesson. The question is, how about the people who live in Bridgeport who can't come up with a lump of money to do the adaptations? Well, if you set up, and Dan Esty worked on this when he was working for the governor of Connecticut, if you set up a program wherein people could go to the state government and borrow money at a rate of interest that was tied to those investments, and a contract to reduce the insurance premiums over a 10-year period that was tied to the property, not to the individual, then they could pay back 4 or 5%, which is really good for the state. You can't find 4 or 5% as a return. They're going to get an internal rate of return of 15%, which means they're actually going to get money back for doing this at the rate of 10% of the cost of the investment. So that's an example of what economics can say, even if it's not going to add everything up, and what thinking about this as a risk-based question can actually portray, and opportunities that become pretty easy to see if you look at it that way.
I'm glad I asked the question, because it really, that was a very, very interesting in terms of thinking about the kind of the whole role of the assessment in terms of hopefully helping all of us be able to see then the things that we need to look at for planning, and hopefully, as you were saying, for all decision makers, including all of us as, you know, in terms of residents in communities looking for ways to mitigate our own risk. And which, living here and looking at that 71% chance of increased precipitation for the whole Northeast, and what we've been seeing for extreme weather events, pretty telling for those of us who also rely on sump pumps, right? So anyway, I think that is all very, very interesting, and I hope that we all find ways to help make sure that we really tap into the climate assessment and encourage people to really look at that website and really make use of it. A couple last questions. Go ahead.
I've heard the term "the new normal" described, or I think Gary mentioned it at the end of his presentation, and I'm a little troubled by that, because it seems to me that as long as we keep pumping more greenhouse gases into the atmosphere, there is no new normal. The new normal will be increasingly destabilized weather and further chaotic results. So new normal is actually, there's no new normal. It's worse and worse.
Yeah, no, that's what I meant to say.
It's
the old
new
normal,
abnormal.
The old normal is broken. We have no idea what the new normal is going to be.
Right, which is what you said, right? Which is extraordinarily sobering. Any other last questions or comments? Okay. Last question.
Hi, I'm Laura Windecker. I'm a Canal Sea Grant Fellow. And my quick question is, I was wondering if you could talk a little bit more about the data that you are expecting, or some of the data that you would love to, that you couldn't put in the assessment this time, but things coming down the tubes that you wish you could have included?
We have a pilot program underway that was proposed by our committee, and hopefully it will continue on. It's an indicators program. So if this is going to be a risk management problem, it's actually an iterative risk management problem, which means that you have to keep track of something to see how well it's working, to be able to make adjustments. And so the question for that group of people is to try to figure out a small collection of things that keep track of how the climate is changing, how decisions are being made, how well they're working, how sensitive they are to international decisions about emissions or something like that. But you can't keep track of all of that, and if you did, you wouldn't know what to do with it because there'd be too much of it. So it's a really fundamentally hard question. Of how is it, what is it that you try to keep track of so you collect the information that will inform your decisions. And we hope in 2018 that we'll be able to report something like that. The analog is inflation, because inflation is based on an index of a variety of things that on the national level you keep track of, but you can also do it at a local level so you can get a dispersion of the rates of inflation across the economy and an economic aggregate. The economic aggregate is good for making economic policy at the federal level, not at all good for making distribution of income decisions at a local level. So you need both, but they have to be consistent. I noticed a former student of mine sitting there, and he's trying to raise his hand. Maybe we'll let him ask a question.
Thanks, Gary. First of all, thank you both for all your work on this over the past several years. It's an incredible service to the country. The report has gotten a lot of media coverage, and that's really great. You all have done a really commendable job of framing this in terms of risk and doing the analysis in terms of risk. I was wondering what you thought about how the media has responded to that framing and how well it's portraying that.
Great question. You both need to respond to this.
Don does more of this than I do, so we'll let him go first.
Well, I do more interviews, maybe, and I'm not sure I do more of that of risk-based analyses. I think Gary wins there. But overall, I think the media has responded quite well. The last few days, we certainly have seen a bounce back by the communities, the blogs and websites that do not accept climate change. But it's been kind of interesting. Climate Nexus puts together kind of a daily analysis of what's going on in the media, and I receive that every day, and it's been rather a weak response. They haven't been able to look at the report and find really things wrong with it, and I think it's bothering them. So we know of a few errors, but they're minor errors. But
you're not supposed to say that.
It's always the case. No matter what you write, there's always some errors. Overall, the press coverage has been quite good, and it has been looking at it from this risk-based approach. I think several of the messages that have really come across is that this is not something for the future. We are seeing climate change. We're seeing dangerous climate change now because of the changing trends in severe weather, but that's also creating this environment where we need to be looking at things differently, where we need to be looking at it in terms of risk and what that means to us in terms of adaptation and mitigation. And what I've seen in many of the articles I saw after our interviews, that seemed to have come across. It was funny, while we were talking, I got a text from my youngest son, and it was a picture of me. I thought maybe it was live because I was sitting in front of a thing like this, and ended up it was from, because I could tell by the tie I was wearing, it was from Tuesday's White House event. But
My experience has been the same. I think the reaction has been really good. Some of the criticism has been muted and generally targeted at old drafts, which I find fascinating. The one thing I can add to what Don said is that there's been international interest. Al Jazeera was interested, BBC interviewed me, I was on a radio show for the Voice of Russia, so that's really cool.
Well, that is really good to know, and I know that there are a lot of communities across the country that are really looking at this very, very seriously as they are really looking at plans, since they are the first responders in terms of having to deal with all sorts of emergencies and looking at the impacts on their communities. And so I want to thank both of you very, very much for speaking here today, but also for your ongoing work to make, because it really, really is incredibly important in terms of thinking about having tools that people across the country can really use to better understand what is happening in terms of trends and what does that mean in terms of trying to address them and make our communities more resilient to dealing with this, and what that therefore can hopefully mean with regard to mitigation. I want to mention also that we will be doing a series with regard to looking at some of the regions that Gary and Don talked about in terms of regional impacts, and we will have one coming up on the Southeast on May 22nd. We already did one with regard to the Southwest, and we're going to be taking a look at the impact on national landmarks and parks on May 20th as well. And we're going to look at the Midwest in, I think, July. So we'll be back talking to both of you, since we all need as much help as we can get from people who have spent so much of their lives really trying to help the rest of us on this. So thank you all very much for coming, and thank you very much, Don and Gary. Really appreciate it. Good afternoon, everyone. My name is Carol Werner. I'm the Executive Director of the Environmental and Energy Study Institute, and I am so pleased to see you here this afternoon with us as we take a look at the National Climate Assessment, which was just released 2 days ago. And of course, the whole purpose behind the National Climate Assessment was to really look at what is happening with regard to domestic climate impacts. We are so fortunate to have with us today two people who played incredibly important leadership roles with regard to the process and the organization and to the writing of this 800-plus page National Climate Assessment. Both of our speakers were involved in the Federal Advisory Committee and were part of the National Climate Assessment team, and as I said, played incredible leadership roles on this assessment, and they both have been involved with the prior assessments, as well as both having been part of the Intergovernmental Panel on Climate Change and being part of that team as lead authors for years. And in fact, both of them were part of the team that was recognized for their work with the IPCC in terms of receipt of the 2007 Nobel Prize. So we are very, very fortunate to have with us today Dr. Don Webbles and Dr. Gary Yo. And a couple things why we are also very lucky to have them is because guess what? We are at the end of the academic year, and so they both are dealing with students in classes which finish up next week, and so we feel very privileged that they are taking this afternoon to spend this time with us, given that very hectic schedule as well. So both are very, very distinguished in terms of their professions. And of course, Dr. Yo is a professor of economics and environmental studies at Wesleyan University, where he has been for more than 30 years. Dr. Don Webbles is professor of atmospheric science at the University of Illinois. And I think a couple other things that I just want to mention is that Dr. Webbles has done so much work and authored so many science articles, and of course his involvement with regard to the impact assessment has been really...
With climate change, you get a lot more colors scattered around the country. Climate change is what the security and defense community calls a risk enhancer. It isn't necessarily the absolute cause of one thing or another, but it amplifies the manifestations of other sources of stress. So what is fundamentally new about the assessment? There are many new topics that had never been covered before in a national climate assessment. The first two, oceans, a special chapter on coasts, a special chapter on urban, rural communities, land use, indigenous peoples. There is a cross-sectoral chapter that links energy, water, and land. And all of these were very exciting, and the committee that helped organize things got a lot of encouragement from a lot of people to try to do these sorts of things. There is a brand new format for the release of the document. One of the talk show hosts on Tuesday night said, I can tell you what's causing climate change. It's another 842-page assessment, and it's just killing the trees and the forests. Wrong. That 842-page full assessment report is published entirely electronically. You will not find an 842-page brick holding up anybody's door. It is completely interactive. You can go on there, and I'll give you the website at the end. You can go on there, go to a chapter, go to a map, click on the map, get the underlying data, click on a reference, get the underlying reference, click on a reference as well, and get an evaluation of its credibility through the review process and a variety of things like that. It's fun. I encourage you to do it. I think it's NCA 14, or I'll look it up. We also have published highlights, about an 85-page summary document and a 20-page overview that you had an opportunity to pick up. It will be linked to GCIS, a global change information system, and it will include, the big report includes these things called traceable accounts, which not only indicates the references that were used to support the particular conclusions in the document, but also the means by which the authors came to their confidence conclusions. Do I have medium confidence in this or high confidence in this? It's a risk-based approach. So we were not held to the necessity of reporting only very high confidence conclusions. If there were high consequences associated with a medium confidence conclusion, it was perfectly appropriate to put it in the report. There was an extensive review that evaluated how we did with that. The National Academies of Science conducted 2 reviews, one of the first draft, which also went through public review for 3 months, a year and a half ago. The federal agencies made a couple of review passes. The National Academy of Sciences reviewed how we responded to all of the comments. All of the comments are available publicly, and all of the responses are available publicly. The Academy passed it on. There was a final, very thorough government review before the administration finally put it forward last Tuesday. And the links to the underlying data, the references, and the traceable accounts are all available electronically and are all subject to Information Quality Act review under NOAA. So the sectors that are covered, water, energy, you can read them. They are the usual sectors that you would think about. Agriculture and human health receive particular attention. There are 8 regions. From the Northeast, Alaska is big enough to be its own region, the Southwest, and so on and so forth. One of the fundamental differences between the IPCC and the National Climate Assessment is that the IPCC has continents, and the United States is just one part of North America. We have one country, and we have 8 regions here. And the focus of the organization of the report was to look at the diversity of the implications of climate change across those regions so that you can understand the sources of risk and the differences across the regions, and build from the bottom up a picture of what was going on. Then there are a couple of new chapters on responses, one on information for decision support, because from the very first day, the point of creating this document was to help inform decision makers at all levels, from individuals up to the federal government. There's a chapter on mitigation that talks a bit about how you structure mitigation and what's going on. A chapter on adaptation, a chapter on research needs, and what we call a sustainable assessment product, or the actual first product of the National Committee, Advisory Committee that produced this National Climate Assessment, was a recommendation to the U.S. government to promote and fund a sustainable assessment process so that over the next 4 years, because by the way there's another one due in 2018, there will be a process of research and investigation that will be focused on what we couldn't do as well as we wanted to, so that we get around to doing it the next time. Somebody else, not me. The United States Global Change Research Program. The act was crafted in 1990, but I found out this week that it was actually passed in 1995. And for those of you who are thinking about the political feeling in this town in this year, it's astonishing to report that that act was passed in the Senate 100-0, and it was passed in the House by voice vote. Its purpose was to provide the Development Comprehensive Integrated United States Research Program, and so on and so forth. Section 106 says that not less frequently than every 4 years, the Council shall prepare an assessment, a national climate assessment, that integrates and evaluates, analyzes current trends and effects, and helps to mobilize reaction. The first National Climate Assessment was released in the year 2000. The second missed the 4-year deadline by a bit. It was published in 2009. There's the covers of them. I have to remember to move the slides that you're seeing, not the ones that I'm seeing. And the real question that a lot of people have been asking is, so what's new? Some of it was, so what's new since the review draft last year, but what's new since 2009? And as the economists in the room, the first thing I want to suggest is what's new is the risk-based framing that allowed us to organize our thoughts chapter by chapter, region by region, according to at least a qualitative definition of risk, that it is likelihood times consequence. And that allowed a fairly deliberate evaluation of what it was that we wanted to talk about and how it is in traceable accounts we wanted to record how we came up with our conclusions. An example of what it allows you to do is that it allows you to recognize that climate is simply another source of stress and another source of possible change in particular sectors. So here's just an example. Climate is only one of many factors affecting water supply availability. So these are maps of water supply availability in 2050 along a particular scenario. I think it must be the high scenario. Over to the left is without climate change. There is change in water availability, percentage change going down by a little bit or a lot. But
in terms of being the lead with regard to looking at the science. And on the other hand, we are very lucky to have today in terms of Dr. Gary Yo, then the other piece in terms of really looking at what this means for adaptation, how to make our communities more resilient, what is really involved in terms of looking at these impacts. And he has spent many, many years really specializing and developing more and more information, doing so much thought leading with regard to adaptation. The final thing that I want to say before turning over the podium to them is that we all owe a little round of congratulations to Dr. Webbles because he just had a new grandson this week on top of the whole thing. So what better way to talk about something that is so critically important to our future? Dr. Webbles, Dr. Yo.
Yeah, two things, I guess, before I start. Don's grandson was born on Tuesday, and when we were giving the stakeholder event in the White House, there were supposed to be slides behind us showing what was important about the 3 minutes that everybody was talking. And we thought maybe we could sneak a picture of the new grandchild in and say, this is what we're talking about, people. The other thing is, yes, I in fact missed the last day of class on Tuesday, but Linda and I, my wife, were walking down the 4th floor of Russell and walked past Senator Bennett's office. And Senator Bennett's father was president of the university. Senator Bennett and Senator Bennett's father and his grandfather all graduated from the university. I stopped in and the senator gave me disposition for it and forgiveness for having missed class. My students didn't seem to be upset either, so I guess I was... Okay, I'm going to talk for a couple of minutes on the National Climate Assessment, the process, where it came from, get to highlighting the high-level results that were emphasized in the release, and then turn it over to Don to talk about the science. And then I'll come back for a couple of minutes to give you a flavor of the regional diversity of the results across the country. So if I can do this without messing this up, yay. The National Climate Assessment is a product of something called the Global Change Research Act, which created